Hola, ¿qué tal?
Today
Originalmente
I'm
me
going to
dijeron
talk
que hiciéramos
about
la charla en inglés,
a no
pero
holistic
por
matter.
problemas te voy
I
a
am
hablar en
going to
español
talk
y de
about the
otro lado
responsibility
ustedes me
of a
ayudan, ¿de
scientist
acuerdo?
in attempting to
Yo
use
hablo
natural
español,
means
pero
that can be
a veces
used
se me
within
olvida la ciencia
science
en español.
to
Eh,
places that have been
Hoy les voy a hablar de
contaminated.
un asunto
Allow me to tell
no
you a
tan
story.
holístico. Le voy a hablar de la
In the
responsabilidad de un
50s and
científico
60s,
y tratar de
the
usar
world
los
was
medios
different and we had the Cold
naturales que se
War
pueden
paranoia.
utilizar dentro de la ciencia para limpiar lugares que han sido
And the United
contaminados.
States stored wheat
Déjenme contarles una
and
historia.
corn
En los 50s y los
throughout the
60s,
country.
el mundo era diferente y teníamos la paranoia de la Guerra
And
Fría.
to keep them
Y
healthy,
los Estados
they
Unidos
added
almacenaron
pesticides.
trigo y maíz a
Eventually,
través
the
de todo el
pesticides
país
reached the soil.
y para mantenerlo bien le
They
ponían
percolated
plaguicidas.
through the soil and have
Los
contaminated the
plaguicidas
aquifers in the
eventualmente
United
llegaron al
States.
suelo,
They are
se
aquifers
colaron
in
a
many
través del
areas that
suelo
are
y han
extremely
contaminado
deep,
los
but that
acuíferos
is not a major
en los
problem.
Estados Unidos. En muchas
But
áreas hay
everything in the
acuíferos que son
Midwest of the United
extremadamente
States
profundos y
has
eso no es tanto
aquifers
problema,
that are
pero
quite
todo en el medio
superficial,
oeste americano
and
o
people
de los
drink
Estados Unidos,
water
perdón, tiene
from those
acuíferos que
aquifers.
son bastante
What is the
superficiales
problem?
y la gente
It has been
toma
discovered that the
agua
chemicals
de
that
esos
were
acuíferos.
used to maintain the wheat
¿Cuál es el problema? Se ha
are
descubierto que los
carcinogenic,
químicos que usaban
and
para
that was
mantener estos
discovered until the
trigo
70s. So,
son
people are drinking
carcinogénicos.
water
Eso se
with
descubrió hasta
carcinogenic
los años
products.
70. Entonces, gente
What
está
do we have
tomando
to
agua
do?
con productos carcinogénicos. Entonces, ¿qué es lo que tenemos que hacer? Primero tenemos que
First,
ver
we
cómo
have to see how we can
podemos
clean up. We
limpiar.
have to
Primero
see
tenemos que ver
where
dónde
is the
está la
contamination
contaminación.
at.
Y
And
ahí
there
viene lo que
comes
nosotros
what we
llamamos
call
caracterización
characterization of
de
an
un
area
área
that
que ha
has
sido
been
contaminada.
contaminated.
Y es
And
lo
it
más
is the
importante
most
que
important thing
necesitamos.
we need.
¿Por qué?
Why?
Porque dependiendo de
Because
la
depending on the
caracterización, vamos a
characterization,
tener
we will have
diferencias
differences
en el
in the
método
cleaning
de
method
limpieza
of
de
that
ese
place.
sitio.
So, characterization
Entonces,
has
la
to be a
caracterización
dynamic
tiene que
process.
ser un
We cannot
proceso
just
dinámico.
arrive
No
and use
podemos llegar
traditional
y simplemente
methodologies,
utilizar
but we
metodologías
have to use
tradicionales,
a
sino
method
que tenemos que
where
usar
they are
un método donde
geologists,
haya
chemists,
geólogos,
biologists,
químicos,
computer
biólogos,
technicians,
gente
where
de
we can all
computadora, donde
engage with
podamos
each other
todos
and look for the
acoplarnos
best
unos a los
solution.
otros y buscar la mejor solución.
We have to be
Tenemos que
economically
ser
responsible,
responsables
so we have
económicamente.
to do
Entonces
it
lo tenemos que
faster,
hacer más rápido,
cheaper,
más
and better.
barato y mejor.
If we can achieve these
Si
three
podemos lograr esos
objectives,
tres objetivos,
we can make a
podemos hacer una
characterization. As I say, it
Como
is
les digo,
important.
es importante.
The principal
El
pollutant that
principal
was used is
contaminante
called
que se usó,
carbon
que se llama
tetrachloride.
tetracloruro de carbono.
Carbon tetrachloride
Tetracloruro de
is a
carbono es
unique
una
molecule
molécula
in a
única
way.
en cierta
It
forma.
is one carbon
Es
with
un
four
carbono con
chlorines.
4 cloros.
It turns out that
Resulta que
each
cada cloro
chlorine is
es
electronegative and pulls
electronegativo y
carbon in the
jala
same
al
way,
carbono en la misma
making it
forma,
extremely
haciéndolo
stable.
extremadamente estable.
So bacteria or any
Entonces,
chemical
bacterias
product does
o
not
cualquier otro
destroy it.
producto químico no lo destruye.
The belonging
Entonces,
of
la
carbon
pertenencia del
tetrachloride
tetracloruro de
in
carbono
the
en el
soil
suelo
is
es
a lot
muchísimo
greater than
mayor que
any
cualquier
other
otro
chemical product
producto
and
químico
has been there
y
since the
está ahí
60s.
desde los años 60.
This is the molecule,
Entonces,
and what I want is for you
quiero
to
ver
see
que
how
ustedes vean
stable it is,
qué estable
because it
porque
is completely
simétrica
symmetrical.
completamente.
What is the problem? This
¿Cuál es
was
el
used in
problema?
farms,
Esto
in
fue usado
silos,
y fue usado en las granjas, fue usado
and
en
something
los
called
silos
Quonset
y
huts,
algo que
which
se
are
llama
huge
Quonset
huts
huts,
where
que
wheat
son
was stored.
casas donde guardaban el grano. Grandísimo.
Interesting, what we have
Interesante,
discovered
lo que hemos
is that
descubierto
the
es
use
que el
was
uso no
not
fue
inappropriate,
inapropiado,
but a
fue el mal
misuse.
uso que
For
fue.
example,
Por
in
ejemplo,
these
en
Quonset
las
huts,
casas estas Quonset huts,
what we have found is
lo
that
que hemos
the
encontrado es que
contamination
afuera de las
is
puertas es
outside
donde
the
está la
doors.
contaminación.
We have created
Hemos
methods
creado
to
métodos
detect
para poder
contamination in
detectar en
parts
partes
per
por
trillion.
trillón la
So someone
contaminación.
finished
Entonces,
with their little
alguien terminaba
pesticide
con
bottle
su frasquito de
and did like
plaguicida
this at the
y lo
door.
hacía así en la puerta.
And that
Y
has
eso ha
created
creado
an incredible
contaminación increíble
contamination.
y es lo que ha llevado.
Remember,
Acuérdese,
for it to
para
be
ser
carcinogenic,
carcinogénico,
the carbon
el tetracloruro de carbono
tetrachloride
tiene que
has to
estar a
be in
concentraciones
concentration
mayores
of
de
greater than
5
5 parts per
trillón.
billion.
O sea,
In
son
other words,
concentraciones
those are
bastante
quite low
bajas.
concentrations.
Entonces, si
So
alguien
if
está
someone
así,
did like this, that is
eso no
more
es
than enough
suficiente para
to
estar
be
arriba de
above
las
5
5
parts per
partes por
billion.
millón. Déjeme enseñarle cómo son nuestros sitios.
Allow
Hoy
me to show
todavía
you how
tenemos los
our
silos en
places are.
algunos casos.
We still
En
have the
algunos
silos
casos los
today,
silos han
in
sido
some
eliminados.
cases. In some
Y lo que
cases, the
tenemos es
silos have been
simplemente un
eliminated,
terreno vacío
and what we have
y
is
la
simply an
contaminación
empty
está.
lot, and the
Generalmente,
contamination is there.
los terrenos están cerca
Generally,
de pueblos
the
donde la
land is close to
otra
towns
vez
where people are again drinking contaminated water. Those two here below are instruments that we use to open up the soil without the need to cause waste. And they have sensors to monitor conductivity and other things. And then we can know what is in the soil, in the subsoil, without the need to open wells and have waste. So those are instruments that help us with that. So what do we do? One of the techniques of which I'll be talking about is the creation of iron nano and microparticles that have been used for the destruction of carbon tetrachloride, but have never been able to completely destroy it. What we have created are these microparticles that we have surrounded with an organic material, which in reality is a corn material. These particles are hydrophilic, it means they dissolve in water, and we can inject them directly in the subsoil. So the purpose is, we as chemists, to modify the environment to be able to make the chemical reaction happen. We introduce the microparticles that have organic matter. What happens when we introduce them? There is bacteria in the soil. Bacteria begins to eat the organic matter. It's very happy, eats, it reproduces. And the conditions change. It changes from an oxygenated system to a non-oxygenated system, anaerobic. When the system changes to a non-anaerobic system, there is one thing called redox potential that makes a reaction happen or not. Then we can change the redox potential to values that are less than 600 millivolts that makes the reaction occur. Thus, all this is a supposition before doing it. If that happens, then we can completely destroy the carbon tetrachloride, and the final product in reality will be iron 3. Iron 3 is rust. So we will leave the place without contamination, and we will not create more contamination as other methods use it. First thing we did is, does it work? Then we chose a place. In this case, it's a place in Kansas, United States, and called Centralia. And we did a characterization first. So, do you see the circuits? Those are the silos. The square little houses are what we call concept huts. And we found a place of contamination that can be seen there. The flow goes toward the northeast from the water that is there. And therefore, we knew very well how it is. And this place has the characterization that the water is not moving. It's like a pool. We simply wanted to know, to see if the process worked. So we took the area that is to the west to make a pilot plan and see if it was going to work out. At the end, we did a characterization a bit more detailed, and we discovered there was an area that was a little bit more contaminated. We did not make a square but another shape to cover the entire area. From there, we found that the contamination were above the 2,000 parts per billion in some areas. So the place was highly polluted. We injected the small iron molecules, and the first thing we find is, in almost every case, that the iron goes from the 2,000 parts per billion in almost zero in 2 weeks. So we can completely destroy the carbon tetrachloride in 2 weeks. In this carbon tetrachloride, we have a point that did not work out. Interesting. In that point, we did not inject iron. But it seems there is a physical effect that makes the tetrachloride move and cause the anomaly. Interesting. The product has still worked for more than 4 years and has destroyed carbon tetrachloride that was at that point. To tell you that is the truth, the picture above gives us the chloroform concentrations, which is the first product of degradation. And the second product is a dichloromethane. Then we can see the formation starting from zero. where the chloroform is formed, and immediately the dichloromethane begins to form. As the carbon tetrachloride disappears, the chloroform is formed. The chloroform begins to disappear to form the dichloromethane. The following product is very fast and we cannot monitor it. But what we can monitor is, which is the iron formation. I am inserting iron 0. What happens with the iron? So we do various things. One is, we measure the redox potential, what I said, and we see that the beginning of the system goes below values of -600, making the system start. Afterwards, there is a reaction of electron donor, and the reaction continues happening for up to 4 years because it is a chain reaction. We monitor the oxygen, and we see that the oxygen goes from a higher point and decreases to obtain the anaerobic condition, and iron begins in 0 and rises dramatically to reach bigger values, meaning that the reaction is happening. So at the end, we went from places where they were contaminated at 200 parts per billion to 2016, we almost have no contamination. In various places, we have 100% cleanliness, and there are a pair that have 8% of contamination that are functioning and still getting cleaned. So, a few conclusions of what I have told you. We have to think and be logical in the way in which you make your characterization. And that characterization will give you the method in order to clean. I am not going to read this, but I want to show you a few more examples. This is another example of cleaning that we have used. It is an irrigation system where we have used water in very small particles and have analyzed each particle to form wetlands. So, the water where it leaves the system and reaches the soil has been cleaned by the size of the particle. It turns out that there is an immigration, bird immigration, from the South America. It has a conical shape. They come from everywhere and come together exactly in Midwestern United States and reopen in Canada. It so happens that our programs are exactly where birds fly. The purpose was to form a wetland with the water that we had so the birds could stop in their same immigration and continue onwards. It is a somewhat environmental way to make a cleaning system and at the same time give the area a bit more environmental things, let's say. So, as there is how birds fly, this was the pilot system. When we measured and were sure that each one of the particles will reach the soil without contamination. The one you see there, in the other one, is the final system. When you are looking at it, already a lot bigger and in serious application. And here a picture when we see the wetland and in the middle a duckling, so you can see it's working. Another project we have is the cleaning using trees as cleaning bombs. This is an area that has been contaminated. We make wells. Of different sizes, where we can plant a tree at different 10 feet, 20 feet, even 50 feet. So each of the trees work as a bomb to remove contamination from the water. It passes it through its system and throws it through its leaves. The water ends up clean, and we have been able to have a clean system. Here, as you can see, you see each one of the wells where each one of the trees come. We have used two varieties, one called poplar and the other one called sauce, both native to the area where we are working. We have not brought any foreign tree. At the end, as you see, there is how we have made the wells to put each one of the trees. and we have managed to maintain and clean the contaminated areas with the fighter remediation system. This is the last one of our programs. I brought you a movie, but we are not going to see it. This place has been contaminated, and what we are doing at this moment is placing horizontal wells instead of vertical to extract the contaminants. So there has been contamination, as you see. In this picture, you can see there is a people completely around the contaminated. The pink areas are the areas where contamination exists and where it is at this moment. One of the biggest problems that we have in a town like this is that carbon tetrachloride is volatile and enters the soil through the soil in your house. So you are breathing carbon tetrachloride, and breathing it is a lot more complicated than drinking it. So, for all these houses, what we have to do is create air cleaning systems for each of the houses. In the United States, we have a radon problem and we have radon house cleaning systems. And we use the same system to clean carbon tetrachloride. So it is a commercial system and easy to implement. In this case, we have introduced a horizontal well, and we can extract it. And we are in the cleaning process of this place. It is interesting. The system has close to 500 parts per billion of contamination. Unfortunately, the system cannot be applied any other way or with other techniques throughout the town. So that limits us in what we are going to do. And we are hoping to cleans last from 10 and 20 years, unfortunately. I want to thank the people who work with us. And if you have any question, anytime, at your service. Thank you.